week 7. We got some good stuff planned for today. So we'll go through the agenda real quick. First, I've got some announcements. Then we'll make sure everybody gets a chance to look at the poll and vote in the poll. Travis has some cool news for us. And then we're going to jump into Agile and Lean software development. So originally we were going to do Angular today. George had a conflict, so we moved his presentation out to next week. We'll do Agile and Lean software development today and then Angular next week. And then we'll talk about poll results at the end. So yeah, let's get started. So yeah, again, the GitHub repo, I'm working on getting that updated. I've been a little bit lax in updating that recently, but we should have by the end of today content from weeks 6 and 7 up there. Also the YouTube channel, if you guys haven't checked that out, make sure you go and check that out. There's always some good content there. We do record the meetings, so and we'll I don't know if last week's meeting is up. We'll see if we can get that up, and then this week's meeting will be up very soon after our meeting today. So with that, I'm going to say, everybody vote now on your phones. The poll is up. I believe what is the best way to deploy code? Okay, so make sure you vote in the polls. We'll announce the results at the end. So with that, I'm going to turn it over to Travis for cool news. So we'll get set up here.
Yeah, just 1 second. Share screen. And then we'll do the TV. All right. Where's the, oh, there it is.
Coming through.
I think I'm sharing the wrong screen. I'm sharing the screen on the left, but that one's coming up on the TV.
Yeah, I think you're okay.
Well, like on Hangouts, I'm sharing my left window, but the screen has the right window.
Duplicate the display instead of extend it? Well, extend is easier. So if you come up here to the share screen, stop screen share, and then share it again, you can select the other
screen two.
Yeah.
Trivial. All right. All right. Cool. Hey, everybody, this is cool news. My news this week, I found this today. It's called JS13K Games. And I found this, GitHub is like a sponsor of this, so I was just scrolling through their Twitter today, and I found this, and it's a coding competition for HTML5 and JavaScript game development, where you have to make a game in less than 13 kilobytes. And I thought that was a really cool idea. So you have a whole month to do it if you're interested. It starts August 13th and ends September 13th. So if you want to like just kind of work on it casually or whatever, that would be cool. So as you can imagine, 13 kilobytes to make a game, you can't use hefty PNGs or anything. My PowerPoint presentation for my Node.js was infamously like 100 megabytes, but you got to make a whole game in 13 kilobytes. So that's quite something, you know. One thing I like about this is that this random dude just runs this competition in his free time. And he's like, yeah, we usually get about $20,000 in prizes, but who knows? But he says hopefully everyone that participates can get a free T-shirt plus shipping. That's kind of cool. Here's some partners and stuff, so you know it's legitimate. And then there's like this little article here that's kind of neat that might give you some ideas about it, like if like, you know, what exactly is it, yada yada, and then just like general tips on how to make a game that's less than 13 kilobytes. So you obviously want to minify your code. So if you don't know, minifying is you just get rid of all the white space and make it, it's hard to read, but it makes it, you're technically smaller. So if you get like import a lot of frameworks or whatever, you might see it minified. So your code might be obfuscated. It's hard to read, but yeah, you can, you know, minify your code, compress all your images if you're going to use them. It talks about you might want to do something procedurally generated, so it's replayable like a roguelike or something. And I just thought that was a really cool idea. So if that appeals to anybody, that's the cool news for this week. You can try to make a game using only HTML5 and JavaScript. I believe frameworks of any kind are disallowed. Most probably won't fit into the 13 kilobytes. So maybe it's like a really small like utility tool you could try to include. But I think I read that just like frameworks altogether are not allowed. So jQuery and stuff is probably a no.
I think you said it said it's just by the size you won't be able to include anything, but if you can write like helper functions that are small enough, then go for it.
Sure. Yeah, that sounds about right. So yeah, pretty interesting. I imagine you'd probably want to use a lot of HTML5 like canvas elements and just do a lot of generating stuff as opposed to, like I said, using resources that already exist. And I'm sure you can use CSS as well, of course. So yeah, that's the cool news for this week. I thought this was pretty neat and thought I'd share it.
Cool. Yeah, so if you're interested, yeah. Okay. So yeah. Oh yeah. Okay. So make sure that's working. Okay. So with that, we'll move on to the main topic today, which is going to be Agile and Lean software development. Agile and Lean kind of mean a lot of different things to a lot of different people. So I'm going to do my best to kind of give an overview, kind of how Agile and Lean came about. We'll talk a little bit about the early days of software development, some software development processes like that were pre-Agile. We'll talk about the dawn of Agile and the Agile Manifesto. Then we'll talk about Lean, which has kind of emerged as kind of a subculture of Agile. And we will watch Toast Kaizen. So for those of you who are familiar with Toast Kaizen, we'll get to a rehashing of that. I'll talk a little bit about DevOps because it kind of fits in. And then I hope to have maybe more of a lengthy discussion at the end, just between everybody. I know everybody's kind of experienced Agile in different ways. I know at the places that I've worked, Agile has worked very differently. And so I just kind of be interested in entertaining that kind of discussion. Like, what does Agile look like for the place where you work or in your experience? So. But one of the motivating questions that I want everybody to keep in mind while we're going through this stuff is, how should we develop and deliver software? Like, is there a right way to do it? Or what sort of things do you have to consider when you're developing and delivering software? And on that note, we'll go ahead and get started. And I'll tell you how not to develop and deliver software. So the early days of software development, nobody, really had a good idea of what the capabilities of software were. We had, sort of people that were interested in doing this in their spare time, and they would sort of hack things together, and then ultimately things would be like shipped out as production products, and I think a lot of it is kind of attributed to the fact that software is really complex. It's really intangible. It's not a thing that a lot of people have a really good idea or really good mindset, like a solid idea of how it should work, or how it, computers in general are mysterious to a lot of people. So, but yeah, the hack ship software development process, and we're talking like 1950s, like very early era. That was really all there was to it. As we sort of got more advanced, hack ship turned into something that we now look at as the waterfall model, which is still in use widely in the software engineering and software development industry. So for those of you who aren't super familiar with the term, the waterfall model is a software process model which says I need to understand all of the features that I'm going to be implementing for this product at the outset. I need to define all of the requirements first. If I don't have all of the requirements, then how am I going to know what I'm going to design and implement and test and maintain ultimately, right? So requirements come first. Once the requirements are all done, then I can move on to designing. And then once the design is done, I can move on to implementation. So this is a very linear sort of approach to writing software. And some of the characteristics of the waterfall model is that this kind of engineering process is used by a lot of other engineering disciplines. Engineering disciplines like electrical engineering and mechanical engineering, where it's expensive to redo things after the fact, where you sink a lot of time, of energy, and budget into creating machinery in order to help build these things, build your product. It's not so much the case with software. Software is a very different kind of product. But at the outset of software development, people didn't really realize that. So kind of stick to what you're comfortable with. There was a huge emphasis, and still is in the waterfall model, on processes and tools, making sure you follow the process, making sure you use the right tools for the job. Also, there's a big focus on comprehensive documentation, making sure that by the time you delivered your product, that you have documented all of the features and all of the functionality, how to troubleshoot it, just so that, when you go forward and maintain it, there's no question as to what this system does. And as you can imagine, if you need to have the requirements done ahead of time, if you're a consulting company, you need to have, you need to be negotiating contracts to make sure that, okay, this is exactly what we're specifying is going to be wrapped up in this product and shipped. And then ultimately, above all else, I think following the plan. This is kind of the overarching principle. I need to follow this plan. I have this plan set out from the beginning. I need to follow it through to its conclusion in order to produce quality software. So, and then I think one other kind of telling model that people have used to describe waterfall is the iron triangle of waterfall software. So up at the top, we have things that are fixed, and at the bottom, we have things that are estimated. And so in waterfall, the thing that's fixed is the scope of the project. Remember, I do requirements at the very beginning, so I fix the things. I know exactly from the onset of the project what I'm going to be accomplishing. And what is flexible, what I have to try to estimate as the project goes on, are the resources necessary and the time that's going to be necessary. So at the onset of the project, I may not know how long it's going to take. I may try to estimate these kinds of things, but I may not know. A project could, and waterfall projects are notorious for going over time and over budget for these reasons. So clearly, and I guess I kind of want to, entertain some ideas just from the group here, like, in your experience, why specifically might waterfall be a bad idea, or might not be like such a good idea for the world of software?
Requirements change?
Yeah, requirements change, requirements evolve. And that's true in other engineering disciplines too, but specifically for software. We're one of the most fast-moving industries that exists. So we have to allow for requirements to change. And if you are locked into the same requirements at the very beginning of the project, you have to get all the way through the project before you're able to release a second version, right? Potentially with changing requirements. What else? Yeah, so you write the requirements initially, but you may have miscommunication or misunderstanding of the requirements. And so by the time you've implemented and you've verified that this is, when you get to the verification step, ultimately, your client is not satisfied with what you've written, because not because the requirements weren't clear, but maybe because the developer didn't understand other things, other facets of the waterfall model that make it not or maybe good things about the waterfall model. I can think of one. I mean, at least you know at the very beginning what you're going to make. You don't have to deal with very much uncertainty. If you assume that you've got this one world where things will not change during the development of this project, then then you've got a pretty happy path, right?
Another good thing, these set in stone, particularly documentation and requirements that get locked in after a certain point, are fantastic if you need approval from some outside organization.
Yeah, and yeah, I guess kind of to go along with that, I guess specifically if you're working on projects where you have to integrate or interact with other engineering teams. So maybe I know at Shure, where I worked the past couple of summers, we were interacting with mechanical engineers and electrical engineers all the time. And they are the ones that really kind of abide by this model. And there are other models that they use too, but waterfall model is kind of a traditional engineering model. And so in those cases, we kind of, are forced into this whether we like it or not, if we're going to release the same product that they're releasing, right?
At my workplace, for instance, there's systems in place with things called toll gates, where it's literally the difference between design and implementation. It's like,
yeah,
you hit that toll gate, and one of the pluses is, I guess from a business perspective, at those toll gates, you kick it upstairs, and the upstairs folks say, yes, we'll continue investing money and resources into this project, or can you come back with something that's cheaper before they actually continue pumping resources into implementation development.
Yeah. Other thoughts about waterfall? So, I mean, clearly, I think the overwhelming thing for me is that this idea that we have to follow the plan from the start to its natural conclusion doesn't really work with software because we move so quickly. Because software is naturally evolves very quickly. New technologies are coming out all the time. We want to be able to respond to that, and so there's a need to be able to sort of make our scope a little bit less flexible, or as a little bit more flexible, and our resources and time are perhaps the things that need to be a little bit less flexible. And so in the early 2000s, we had a group of software developers that realized this and all came together and wrote something called the Agile Manifesto. So people, among whom are Jim Highsmith and Robert Martin, Uncle Bob, and Martin Fowler, all came together, Kent Beck, all came together to write the Agile Manifesto. And you can look this up on agilemanifesto.org. What it says is, we are uncovering better ways of developing software by doing it and by helping others do it. And through this work, we've come to value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. So the very things that Waterfall that were the bread and butter of Waterfall were now kind of being turned on their head, right? And then they followed up with, that is, while there is value in the items on the right, we value the items on the left more. So not saying that you should never follow a plan or that you should never document your stuff, right? Because clearly that's not the right answer, right? But we do value the things on the left more than the things on the right. Additionally, you can go in, and there are 12 Agile principles, and I'm not going to go through all of them, but I'm going to hit the highlights here. The highest priority for Agile developers is to satisfy the customer through early and continuous delivery of valuable software. So even as early as the writing of the Agile Manifesto, we have ideas like continuous delivery starting to emerge, things that really haven't taken root until very recently, or become very feasible until very recently. We welcome changing requirements even late in development. And this is one that's, I always have to come back and think about this, because if, this is kind of a core thing that's very different about Waterfall. If you're used to putting a lot of effort into requirements and never having to do your requirements again, well, that's sorry, Joe, you're kind of out of luck, right? This is the way that Agile is different. We welcome changing requirements even late in development. We want to deliver working software frequently, and our clients, the business people, and our developers must work together daily. They must be willing to interact and be willing to have these conversations. There's no more like, okay, let's negotiate a contract, let's get all the requirements set, and then 2 years from now we'll come back and see if you did the right thing. Right? It's a daily process. Face-to-face conversation where possible. Sustainable development. In other words, I'm not working 80-hour weeks all the time to satisfy my client. I'm being reasonable about the number of features and the amount of work that I'm doing at any given time. Technical excellence and good design all throughout the project. Okay, not just during the design phase, but all throughout. And then I think is kind of interesting is maximizing the amount of work not done. Right. A lot of times you think you want to maximize the amount of work that we do, but being agile means that we don't have a lot of overhead, and that's really what we're getting at here. So if we look at the iron triangle of Agile compared to the iron triangle of Waterfall, we see that the things that were estimated before are now the things that are fixed. And the scope, which was fixed before, is now the thing that we try to estimate. We fix our development cycles in sprints, right? Or short increments, 1 week, 2 weeks, 4 weeks. And then within those sprints, we allocate resources, and we have basically a fixed number of developers in those sprints. And then we try to estimate how much can we do, right? Rather than how long will this take or how many developers do we need. So that's kind of the crux of Agile. You may have also heard of Scrum. Scrum is kind of an implementation of Agile. And one thing you'll notice if you read the Agile Manifesto is they never say how to do any of these things. These are just the principles. You can accomplish these in a lot of different ways. And a lot of people have created a lot of different process models to kind of accomplish this. One that's pretty popular and one that we use at Proofpoint is Scrum, in which sort of everything, oh dear. One moment.
Your computer wants you to watch Hot Fuzz.
I guess it does.
It's a good movie.
Okay. So yeah, so we're developing a product and we have a continuously prioritized list of features that live in our product backlog that our client kind of manages for us, or our product manager manages for us. And we come into a sprint planning meeting in which we take things off of the product backlog and put them in a sprint backlog. And that happens at the beginning of the sprint. And then we do our sprint, for us, that's generally 2 weeks. We have one team that works on accomplishing all of the features that we set out to do in the sprint backlog, right? We have daily Scrum stand-up meetings, and so saying that, okay, I'm working on this particular feature, the rest of the team is working on other features that may or may not interact with mine, so I want to make sure I'm updating them on the things that I'm doing, updating them on maybe the problems I'm having, so that we can really work together as a team. It also promotes kind of mutual ownership of the code. No one person is an expert in one area. You want to have everybody be able to answer questions about everything. Once the sprint is done, we kind of do a sprint review. Hopefully we've accomplished everything we set out to in the sprint backlog. If not, we kind of send things back to the product backlog, or maybe we discover that, well, our client really wasn't super happy with what we did, but that kind of sparks new discussions, and then new things get prioritized in the product backlog. And then the things that do make it out is kind of like an incremental release, right? And so the most our client has to wait in order to get any feedback, or in order to give us feedback, is 2 weeks. Right? And this is pretty I would say pretty widely used. There are tools like Jira that a lot of businesses use that come basically prepackaged to do a lot of the things that Scrum dictates that you should do. So that's kind of all I want to say about Agile. Anybody want to say anything else about Agile? This is basically kind of what we do at Proofpoint, yeah. So.
But how does it scale?
Yeah, there's a whole like ideology about scalable Agile and how you can implement this at a larger scale, which we won't be able to get into today, but is a very interesting topic if you're interested. Jim Highsmith's book, Agile Project Management, is good if you want to learn a little bit more about that. So as Agile kind of evolved from the early 2000s to now, we see that Agile isn't, it's still kind of a popular framework. In other words, the principles are good, but we find that even still with Agile processes alone, there's a lot of overhead. Like we have to maintain these product backlogs, we have to maintain these sprint backlogs, we have to do a lot of thinking and a lot of planning at the same time that we're writing code. And so we have a new kind of subculture of Agile, which is lean software. This is the house of lean. And so there are kind of 5 really important components to lean software development. The number one being value. We want to constantly deliver value to the customer. Sustainable shortest lead time, best quality and value, lowest cost, high morale, and safety. That's really what we're trying to achieve. And the ways that we do it are the 2 pillars of lean. So the first pillar is respect for people. So we don't want to trouble our customer. We want to develop people and then build products, which I think is kind of interesting. Normally we develop products and then, I don't know, we don't build people, but I suppose that's neither here nor there. I don't. Not at our company. We don't want to have any wasteful work. And we want to build partners with stable relationships and trust. And we want to be able to coach people that are being onboarded onto our team and things like that. We have to operate on this respect for people. And the other thing that's really important is continuous improvement, or sometimes what they call Kaizen, small changes that have a big impact. Asking kind of the 5 whys, which is another kind of interesting. Well, if you notice a problem in your system, you kind of have to ask, you have to ask the question why about 5 times in order to get to the root cause. So, and then ultimately the foundation of all of this is making sure you have the right support from management. Because if you don't have the right support from management, none of the respect for people or continuous improvement can really happen. So, you notice a lot of these things are kind of similar in terms of the values that we have with Agile, but we have some different focuses. And I think this is, I think it's an accurate statement to say, if you adopt lean engineering and lean engineering practices, then you will be more agile, right? But it's not necessarily the other way around. Let's see, what's our time here? Yeah, we got some time. I'm going to come back to Toast Kaizen. I'm going to talk a little bit. I want to have a little bit of a discussion before this, but we'll see if we can watch Toast Kaizen. It's a good video. But I do want to talk a little bit about DevOps. I guess anybody want to say anything about Lean? Okay, I'll talk a little bit about DevOps first. So, and this is one of the things, if you go all the way back to one of the very first Agile principles that we had, right? Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. We think about that idea of continuous delivery. Our customers should always be able to see the latest thing that we've been working on, and they should be able to give us feedback, because that really helps us move more quickly and be agile. And so, what are some of the ways that we can do that? We think about our software pipeline, which it kind of looks like the waterfall pipeline to some extent, but we have to realize that this kind of happens continuously, and we may be in different stages all at the same time. Ultimately, we have to define what we're doing, like our requirements, and we have to create a design, develop a solution, build it, integrate it with what's already there, test it, make sure that it works, release it, deploy it, and then make sure that we can operate and maintain it. So if you're familiar, there are three big concepts that are kind of related to DevOps. We have continuous integration, continuous delivery, continuous deployment. So Agile will get us about this far to making sure that we can build and integrate our software. But Agile doesn't really give us any context beyond that. If you adopt the next kind of level, I would say, it's continuous integration. Continuous integration says, well, I should be able to continuously integrate my code and run my integration tests or my unit test, integration tests, system tests, acceptance tests on every time that I commit code. Every time that I change my code base, I should be able to verify that my code is doing what it's supposed to do. If you take another step, you say, well, continuous delivery says, if all of my integration tests pass, why not, get as far as I can to deploying it, right? Maybe deploy it to a staging environment where I can actually verify and see that the whole system is working. That's kind of an important idea. And then some companies will go even as far as to say, well, if I use continuous delivery and maybe I add in a few other things like feature flags, I can really achieve true DevOps, which is I make a single change in my software and it gets propagated through the entire system into what is actually running in production, what is actually being operated. Not a lot of companies are here yet. And even the best companies have issues with this. And I think this is particularly an exciting kind of thing to be looking at, an exciting world to be in at the moment. So, and that's all I want to say about DevOps. So, I do want to have a quick discussion here. So, we've talked about a lot of different things with Agile. I want to hear some is this pretty much what you do at your company, or is your company not super agile, or what are kind of your feelings about Agile? Yeah.
One quick question first.
Yeah.
You mentioned feature flags.
Yeah.
What defines a feature flag?
Yeah, so we do this a little bit at Proofpoint. Basically, the idea is with a feature flag, I can separately from if I'm continuously deploying my features, I may not, and I don't know that they're necessarily ready for production, but I'm still committing my code to production. I need a way to turn my feature off, right? If it's not well implemented or well tested, right? And that's really what allows us to get into production. So let's say you may commit your feature to production, but behind a flag. So maybe your quality assurance will go on and turn on the flag when it's ready to be used by your clients or by your customers. That's kind of the idea with a feature flag. Yeah.
This sounds like Git branches.
And to some extent, they could be essentially it's So you have a feature, perhaps you're developing it in a branch, but let's say it's maybe you're developing a new UI component for some other piece of functionality, and you don't really want to turn that on in the UI until it's been thoroughly tested. But you do want to commit and deliver your code to production in order to make sure that there's always the latest thing is in production, right? And so, and you could argue about, well, okay, why are we actually putting these things in production if they're not actually ready to be, seen by our client, right? And so, there's that argument too.
If you do it well, it's just a really simple way to you change a false to a true in a config file, and suddenly you have a whole new feature. It's just easier especially for people like QA that aren't as good at Git in our case.
Yeah.
Or just whatever. I mean, it's just a really simple way to keep track of features. I kind of like it.
Yeah, I think it's a cool concept. I think there's a lot more research that has to be done about what's the best way to do it and things like that. But it certainly does allow you to push all your code to production all the time. The one thing I'm interested in is like how many people are working at a place where you generally use pretty agile processes. Like, is that something that I mean, we have somebody at our works. We have somebody that says, well, we pretty much use Agile Fall, which is the worst of Agile and Waterfall combined. Which he may be a little bit cynical or maybe just joking, but I mean, it can feel that way sometimes.
I think sometimes you can get stuck in that situation, like I mentioned earlier, regulations. Oftentimes it's like, well, we want to be agile because we want to especially because we want to get to these things. We want to be able to be rolling out new features as we like have good ideas, or as customers come to us and say, you know, I really wish this software did XYZ. And we'd be like, oh, we can do that. But there's a conflict between that and software needs to be validated. And sometimes that doesn't just mean internally validated. Sometimes that means you need to ship it to ISO, and ISO needs to say, yeah, this looks good. Or even worse, sometimes you need to ship it to FDA, and the FDA needs to stick it in someone's desk for 2 years and then eventually pull it out and say, yeah, that looks good.
We talk about stand-up.
Talking about stand-up?
Like, we can talk about it.
Yeah. So, I mean, everybody kind of does stand-up a different way. I know the way that we do it at Proofpoint is like, we schedule our stand-ups for half an hour. That's kind of long for a stand-up meeting. I mean, everybody's standing up for half an hour. But we have a big team. And so the idea is you want to get through everybody and make sure everybody has a chance to like say what they're working on and things like that, and bring up issues if there are issues. But a lot of times you don't want to have like long discussions while you're trying to make your way through what everybody is doing. And so the way that we've kind of found our way around that is by using a concept of an after party or sort of a hopper. So you have, you know, people say, well, I might have an after party on a particular issue, and that basically means they want to talk about it for a little bit longer. So after everybody has made it all the way around and they've said what they're working on, if there are outstanding issues that need to be discussed, then we can talk about it. But it at least gives everybody a chance to update on what they're doing. So.
Yeah, stand-up is like, it's probably the most processy thing that you actually interact with on a day-to-day basis because you do it every day. I know a lot of people in our office have a problem. They think it's too long or think that it should be split up, which I guess gets into like a scale issue. So,
yeah.
Like if your team, like at a certain point, like who needs to listen to what Joe Blow is doing today? You know what I mean? Like it's kind of, it can take up a lot of time.
Yeah. I mean, at our stand-ups, we can have on, just depending on how many people are there and are available, we could have anywhere from 6 people in stand-up to like 15.
Yeah.
We do basically stand up during our weekly, I'm going to call it a scrum meeting, even though we are not very strict about like the actual process of any of this. Like we're not like philosophies, not processes, very much for the most part. But stand up we often do through, there's an integration for HipChat, which we use. I'm sure they exist for Slack and IRC, that like you submit your stand up report for the day or for whatever period of, yeah, probably for Teams, you know, if you hate yourself. You submit your stand-up for the day, and then you can check just like for whatever channel you're in, you can check whatever the last stand-up report that everyone has submitted is. So you can update them asynchronously. You don't ever need to get everyone standing up all at the same time. If you change tasks at lunch because you finished something, that can get reflected in this way. And I think that kind of brings that DevOps philosophy back into the earlier stages that Agile traditionally covers. Because continuous integration, yes, is tools, but it's more of a philosophy. And the tools like Jenkins or whatever exist just to automate that philosophy. Similarly, like some sort of electronic record stand-up like this exists to automate this stand-up idea that lets you that lets everybody keep track of where everybody is and pick up slack where it needs to be picked up.
So just really quickly, for those who aren't aware, Jenkins is a build server. So there are lots of different build servers that exist. You can have your GitHub repository linked to any number of continuous integration servers. I use Travis CI most of the time if it's on GitHub. GitLab has it built in, which is nice.
Except by default, it emails you whenever something fails.
Yeah, which is kind of not great, but you can try. I guess you can modify your notifications.
That's true.
But yeah, it doesn't really matter what tool you use. But I know that in my experience, if you spend the time to get the infrastructure set up in order to continuously test your software on every commit, then the chances that if your team all commits to the same philosophy of we're going to test our code and make sure that it works, then you run into a lot fewer problems down the road when you're trying to integrate everything together. And a lot of times that's kind of like an ideal world. You have to talk about you could talk about the difference, or ideally we would want 100% test coverage on everything. But number one, 100% test coverage doesn't tell us anything. Number two, even if we were to get 100% test coverage, a lot of times that's not really achievable or attainable, especially depending on how the design of the code is. Right?
So one thing I think is worth mentioning, I work in a regulated industry, life sciences, so we do, and we work with machines. So we do subscribe to essentially the waterfall method because, well, as the software people are figuring out, are we using the cloud? Are we using cameras? Are we using users? The manufacturing people and the mechanical design people, they're also figuring out, well, how many arms and legs is this thing going to have? But one thing that's important to remember is that even in Waterfall, you can still try to pull in a lot of the ideas of the Agile manifesto of keeping the customers engaged, pulling out, if not rapid products, rapid prototypes, bring them in, say, hey, here's a foam cardboard box with a stupid little prototype UI attached to it. What do you think? How would this work in your everyday job?
Mm-hmm.
And not even just the customers, because this isn't necessarily useful for software, but we have to do the same thing with the manufacturers, because you might want this beautiful cylindrical design trash can or something, but the manufacturers are going to go, it's got to be either a triangle or a rectangle. We don't do circles here. Not without a 200% price increase. So it's important to have everybody on board and be communicating and iterating no matter what process you're using, Waterfall, Agile, whatever.
Yeah. It kind of reminds me of we talked about a lot of different kind of software process models in 372. It kind of reminds me of Spiral, where you iterate a little bit, and then once you're pretty confident that the customer is going to be satisfied with your design, then you do kind of a waterfall, sequential, linear kind of, okay, let's really spec out the requirements, design, implement, test, release. Okay. Oh, yeah, you have a thing?
For people that work in workplaces that do really hardline do these processes in blocks of time or concrete roles, do you think that's actually helpful to the philosophy, or would it be more helpful to you to just let these be guiding principles rather than a firm structure? I'm not sure how much sense this question actually makes. Well, it's kind of half-baked.
I think, I guess the way I interpret it is, I think of Agile as kind of an interface, right? Agile is kind of the goal or the standard, but Agile itself does not define the process.
Exactly.
Scrum is a process which implements Agile, is what I would say.
But I'm saying, do you think that adhering to a strict process like that or adhering exactly to a process actually is helpful, or do you think it's more of a hindrance?
I think no matter what process you use, you have to kind of tailor it to the team that you're working with and to the company where you work. And I think that's kind of a cop-out answer. But
Sure.
like, I mean, in general, you have to have discussions like, okay, this is the general model we want. I guess then the other thing you have to think about is, like we were talking about, scalable Agile. How well does your process scale when you're trying to work with other groups at other levels in the company, right? If, I think about my time at Shure when I was doing, software quality assurance for multiple different, products. A lot of it was embedded software, and so we were working with computer engineers and electrical engineers that were designing, that were, a lot more in the weeds in terms of actually, like, working on and iterating through this, through this product. And they're kind of stuck more in a waterfall model themselves. So for us, it made sense to, like, only be testing this particular product when it was in the final stages, right before it was released as a product. So I think a lot of it also depends on, like, other kinds of engineers and other engineering disciplines that you have to interact with. It's a good question, though. Other ideas on that? People online, you're welcome to chip in, or also I'll check the Google Hangouts chat as well. I think it's interesting from my perspective, coming from a quality assurance, but the first internship I did was with a quality assurance group, and not so much like like what we talk about in the class, like our software quality assurance class at Rose, is a lot more from the development perspective. How do I know that my software that I'm writing is of good quality? Well, I have to write unit tests and things like that, and system tests, integration tests. But if you're working at a company where you are interacting with, your software, it's not really so much that you're just testing the software, you're testing the product as a whole. You're doing quality assurance. I mean, your title may be a software quality assurance engineer, but you're really testing the quality of the whole product. I remember I was testing a physical device by pushing buttons on, like, a device that had been fabricated and manufactured, and we'd load the latest firmware onto this device. So I think quality assurance can take a lot of forms too, at a lot of different levels. Right? Okay. Cool. All right, so I think here's what we're going to do is we'll announce the poll results. We'll talk about next week, and then for those who want to stick around and watch some of Toast Kaizen, we'll do that. I'll send out the link for Toast Kaizen as well for those who are online. I won't stream it over Hangouts because that will probably not be very good quality. But I will send out the link for Toast Kaizen. So, okay. So let me move back to week 7. Yeah, so next week, like I said at the beginning, we're going to be talking about Angular. That'll be George. So looking forward to that. I know a lot of people are really interested in that kind of thing, single page applications and front end development. So yeah, so that will be next week. Make sure you tune in for that. Also, we haven't talked about the single greatest SSH technique that exists yet. So maybe we can wrap that in next week as well. So also now is your last chance to vote in the poll before I read the answers. So make sure you get your votes in. I guess it looks like there is a clear winner here. So the poll was, what is the best way to deploy code? We had the #1 answer with 5 votes. Mail it to Amazon. So there you go. Okay, cool. Anything else? All right, thanks, guys.